So again, question 4, we want to solve the following logarithmic equation. Again, one of the things we pick up on is we need to identify the domain restriction to start with. So 4x plus 6 has to be greater than 0. So if I move the 6 over, 4x is greater than -6, divide by 4, that's going to be -6/4. And since you can divide the top and bottom both by 2, that's going to be greater than -3/2. So again, if you divide 6 divided by 4 and do math, fraction, you'll see that that's going to be 3/2, but a negative divided by positive is a negative. So notice how though that, so I can use a -1.5 there as well to help me kind of visualize this a little bit better because I'm better with decimals. Notice that x minus 7 has to also be greater than 0. So x has got to be greater than 7 as well. So you actually got to meet both conditions. So if I look at it from a number line perspective, -1.5, here's 0. So -1.5 will be over here. So you got to be greater than -1.5, but you also got to be greater than 7. So to make both conditions, you actually have to be greater than 7. So we have to be greater than 7. If we're not greater than 7, then we have to throw that out. So now let's figure out how we want to solve this problem. Since I would like to say, I can set these logs equal to each other, but this one kind of gets in the way. So to me, the easiest thing to go ahead and do is just move this log of x minus 7 over here to the other side. So I'm going to have the log of 4x plus 6 minus the log of x minus 7, and that's now going to just equal 1. Now, the reason I did that is I can now make this a quotient. So this is going to be the log of 4x plus 6 over x minus 7 equal to 1. Now, remember, since this is a common log, this base is understood to be a 10. And since this is just a single logarithm, we can use exponential form to do this. So the 10 to the 1 comes together. And that leaves me then the 4x plus 6 over x minus 7. So we have that going on. So we have 10 to the 1 is actually going to be 10. So this is going to be 4x plus 6 over x minus 7 is equal to 10. And we can put this 10 over 1. And since this is a proportion, we are allowed to kind of cross multiply. So 1 times 4x plus 6 is going to be 4x plus 6. And then we'll have 10 times x minus 7. So I have 4x plus 6, and then if you multiply the 10 through, that's going to be 10x minus 70. Now to get x by itself, we pick on the little guy, which would be the 4x. So I want to lose a 4x here as long as I lose a 4x over here. So that's going to give me then, bring this over here a little bit, 6 is going to equal then 6x minus 70. So then the 70's got to come over here, make that a 76 equals 6x. And then we have to divide by 6 to get the x by itself. So 76 divided by 6. So that's going to be a decimal, so we need to probably make that a fraction. So go math and make that a fraction. So that's going to be 38 thirds. So 38 thirds is going to be what x is. And notice that was 12.6, so it was greater than 7. So that should be our solution is 38 thirds. So 38 thirds would be our solution set. So if we wanted to check this, we could substitute 38 thirds into the problem and see if it really does work. So the log of 4 times, again, I could come up here and paste this in. Well, let's just do the 33rds. It looks like too much complication. Let's just paste that in there. Close parenthesis. Oh, we got to add a 6. And then close the parentheses. So 4 times 33rds plus 6. That equals then that. Then on the other side, we have this 1 plus the log of, then we can paste that 38 thirds in there, minus 7, close parenthesis, and do we get the same answer? Yeah, we do get the exact same answer, so 38 thirds does satisfy our problem.